All right, so we are going to move on to solving a quadratic equation by graphing and finding the x-intercepts of a parabola, because these are completely connected to each other. So first of all, let's talk about solving a quadratic equation. This is something that you are familiar with already. We solved equations in the past that might have looked like this. 0 is equal to x squared plus 3x minus 4. We solved equations like this in the past. And the way in which we solve quadratic equations before was to set them equal to 0, which this one already is, and then we factored the quadratic. So we would factor this right side of the equation into, hopefully you remember, x plus 4 times x minus 1. Again, finding two numbers that multiply to be -4 and add to be 3. From there, what did we do? We broke it into two separate mini equations, x plus 4 equals 0 and x minus 1 equals 0. And then we solved both of those two mini linear equations to get x equals 4 and x equals 1. And what we found was that that equation had two solutions. What I want to do now is connect that to graphing. Okay, so I'm just going to scroll down here. I'm going to grab this. I'm going to bring this over here. And I'm just going to leave this here for a second. Once I get it there, I'm going to ask you what you notice. This is actually the graph of the equation y equals x squared plus 3x minus 4. It's the same thing as we had here, except it's y equals instead of 0 equals. So I just want you to observe that for a moment and tell me what you notice. Well, hopefully you noticed these numbers appearing in that graph. I'm sorry, I actually had somebody hopefully caught this. This first solution was not x equals 4. It should have been x equals -4, right? We would subtract 4 from both sides. Let me fix that. I apologize for that. So that is x equals -4. Okay, so two solutions, -4 and 1. And now things might be a little more obvious. Look at your graph. Look at where these are important numbers, right here and right there. So now think, why? Why did it work out like that? I take this quadratic, I factor it, and I get x equals -4 and 1. And it just happens to be that that's where my parabola crosses the x-axis. Yeah, that's exactly right. Because in our quadratic equation that we solved up here, y was equal to 0. I gave you 0 equals x squared plus 3x minus 4. So I was telling you instantly that the y value had to be 0. And where is the y value equal to 0 on a graph? Right here. And anywhere on this line, any point that falls on this line is going to have a y value of 0. And so this is pretty interesting. If we graph a parabola and we can see where it crosses the x-axis, or we call those the x-intercepts, right? The x-intercepts. Those are going to be the solutions to our quadratic equation when it's equal to 0. We also often call these points the zeros. We call those the zeros of the equation. All right. So these two ideas are connected. Things from that we've talked about before, factoring and solving, and then graphing it and seeing where its intercepts are, its x-intercepts are. Let's take a look at a couple other ones. So let's say we had to let's do this one next. So we're going to look at the equation y is equal to x squared plus 3x. And your job is to find the zeros or find the x-intercepts of this graph. So maybe pause the video and see if you can do that, and see if you can do it two different ways, right? So we're going to find x-intercepts. One, by factoring, set it equal to 0, right? Set it equal to 0 and factor. And two, by graphing it, right? So we're doing a little bit of combining past ideas and combining new ideas and merging them and seeing how they are connected. All right. So go ahead and pause and see if you can do that for now. So I went ahead and graphed this parabola, and you can see it right here. Okay. So I went ahead and graphed this parabola, and it looks like this. And what I noticed right away is that it's crossing the x-axis here and here at -3 and at 0. Can we confirm that using some factoring? Well, let's set it equal to 0, because that's where y is equal to 0 on that x-axis. And then we will factor it. So this one, you'll maybe notice, only has two terms, and there happens to be a GCF, a greatest common factor of x. X times the quantity x plus 3. I'm factoring out of x. And then what I do is I take this and this, break them apart, set them both equal to 0. And I get x equals 0 as one solution, and x equals -3 as the other solution. Does that match up with what we had here? -3, -3, 0, 0. So we can do these by graphing, and we can also do them by factoring. So let's look at just a couple other scenarios that could play out. So let's do next one that's a little bit different. So I'm going to do y is equal to, so we'll do the same idea here, but this one turns out a little different. Y equals -x squared plus 6x minus 9. Okay, so I want you to try to graph this first, and then we're going to do the same thing where we factor it. Now, one note about the factoring, we set it equal to 0. I'm just going to give you a boost in your thinking here. Whenever we have this leading coefficient that's negative and we factor, do you remember what you need to do first there? Always factor out a negative, even if it's just -1. So the very first thing we want to do is factor out the negative here, which is going to change the signs. It's going to change it to x squared minus 6x plus 9. And then that should help your factoring here. So go ahead and pause the video, graph this original equation, and then continue this factoring. So again, I went ahead and graphed it, and I'm bringing it over here on the right-hand side. And so what maybe you noticed is that when we graph this, first of all, it's an inverted upside down parabola. It's opening downward. That's because of this negative leading coefficient. But when you start to look at the x-intercepts, the zeros, it only touches that x-axis in one spot. It's one of these parabolas where the vertex is actually on the x-axis. And so the only solution to this, the only x-intercept, is at x equals 3. Let's see if we can confirm that through this factoring. So 0, let's continue. 0 equals negative. This quadratic inside the parentheses factors to be x minus 3 times x minus 3. Again, two -3s multiply to be a 9, and they add to be a -6. And because this is just a single number out here, we can ignore that when setting up our mini equations. X minus 3 equals 0, x minus 3 equals 0. This one would not give us any new information. So what happens when we solve these? X equals 3 and x equals 3. We get a repeated solution. It's the same number. when that happens, anytime you're factoring and you get the same number in that quadratic, it is telling you that your quadratic is just going to touch that x-axis once. It only has 1 0. Let's do one more. And this one is, let's do y is equal to x squared plus 3. So let's go ahead and do the same thing, see if we can graph it, see if we can find its zeros. So again, I went and graphed this, and you can see it right there. And so if we're looking at the equation, y equals x squared plus 3, and we compare it to the graph, and we're thinking, what are the x-intercepts? What are the zeros? Well, this one actually does not cross or touch the x-axis at all. So there are no x-intercepts, right? There are none here. That's going to happen sometimes. And we can confirm that over here. If we say 0 is equal to x squared plus 3, you might be wondering, well, how could I factor that? Well, yeah, this isn't really factorable. And one thing you might even have tried or just looked at is, what if I subtract 3 from both sides? -3 is equal to x squared, or flipping it around, x squared is equal to -3. If you just think about that equation there for a second and what it means, squaring a number, we're multiplying some number by itself, and we're trying to find what that number is, but the result is a negative number. If you'll think through that, that can't happen. There's no way to multiply any number by itself and get a negative number, because if that number is positive, a positive number times a positive number is always going to be positive. And a negative number, if it's negative, if you multiply it by itself, it's also positive. So there's no way to multiply any number by itself and get a positive number back. And so this means that there is no solution here, no real number solution. You'll learn about imaginary numbers at some other point. But for now, there's no solution, which is going to be the case when our parabola does not cross the x-axis. So when you were trying to find the zeros of your quadratic equations, or when you're trying to find your x-intercepts, there are 3 different scenarios that can happen. This is just to summarize. You can have 2 solutions or 2 intercepts, which would be when your parabola looks like this and it crosses twice. You can have 1 where your parabola might just touch the x-axis at one spot, and you can have 0 where your quadratic equation, your parabola, just does that, and the vertex is above the x-axis or below the x-axis. And so those are the different scenarios that can happen when you are trying to find the x-intercepts of a quadratic equation or solving those quadratic equations by graphing.